Look up at the night sky, go on, step outside, away from the city lights if you can. What do you see? A velvet blackness sprinkled with the diamond dust of distant suns. Each one of those points of light is a star, much like our own sun. And, we now know that most of those stars have planets. Some are gas giants like Jupiter, others are rocky worlds like Earth. Our galaxy, the Milky Way, contains hundreds of billions of stars. And, actually, there are hundreds of billions of galaxies in the observable universe. The numbers are staggering, almost beyond human comprehension. It's a cosmic ocean of unimaginable depth, teeming with worlds. So here's the question that should keep you up at night. With all those worlds, all those chances for life to arise, where is everybody? Our radio telescopes have been listening for decades. They are our electronic ears, pressed against the cosmic void, straining to hear a whisper, a signal, a simple hello from another civilization. But all we hear is silence. The background hiss of the universe. The faint echo of the Big Bang. No alien soap operas. No interstellar news broadcasts. Just the quiet hum of empty space. It's one of the most profound and unsettling mysteries in all of science. This great mystery has a name. It's called the Fermi Paradox. It was famously posed by Enrico Fermi during a casual lunch conversation back in 1950. He was talking with colleagues about the high probability of extraterrestrial life. Billions of stars, many older than our sun, high chance of Earth-like planets. He reasoned life should have arisen many times, and once it did, intelligence and interstellar travel could follow. So, after that quick calculation, he asked a simple three-word question. Where is everybody? It's a paradox. High probability, zero evidence. Imagine a gigantic, beautifully decorated ballroom with millions of invitations sent. You find the room completely empty. The music is ready, the tables are set, there are no guests. You'd start to wonder, did you get the date wrong? Did something stop them? Or is there something more sinister? The Fermi Paradox forces cosmic-scale questions. Step 1. Our galaxy is vast and ancient. Hundreds of billions of suns, potentially trillions of planets. Raw materials for life, carbon, oxygen, nitrogen are everywhere. To explain this cosmic ghostliness, scientists have proposed a chilling concept, the Great Filter. Imagine life as a series of evolutionary steps, from its very first spark to a galaxy-spanning civilization. Non-living chemicals to simple cells to complex ones, single-celled organisms to multicellular life, simple animals to creatures with big brains, intelligent beings to spacefaring explorers. The Great Filter is a proposed challenge or barrier so difficult it stops almost all life from reaching high technological levels. It's life's ultimate test. The failure rate is astronomically high. This filter could be anywhere along that timeline. It could be behind us. It could be right here with us now. It could be waiting for us in our future. Let's consider the first possibility. The filter is behind us. This is the optimistic scenario. One of the steps we've already passed might be incredibly rare. Perhaps abiogenesis, the jump to the first self-replicating molecule, is the filter. Maybe the leap from prokaryotic to eukaryotic cells, which took over 1 billion years, is the hurdle. If so, we might be among the first technological species. We could be alone or nearly alone in an empty cosmos. Now the sobering idea, the Great Filter is happening now or lies ahead. This is the terrifying possibility. One possibility for the Great Filter is that the universe itself is just too dangerous a place for life to survive for long. We tend to think of space as empty and peaceful, but it's actually more like a cosmic shooting gallery. Planets are the targets. Our solar system drifts through the galaxy. Its journey is not always a smooth ride. One of the most violent events is a supernova, the explosive death of a massive star. If a star went supernova within a few dozen light-years of Earth, it would blast our planet with so much high-energy radiation that it would strip away our protective ozone layer, leading to a mass extinction that would sterilize the surface. Supernovae aren't even the biggest guns. Gamma-ray bursts, GRBs, the most powerful explosions since the Big Bang, caused by the collapse of hypermassive stars or the collision of two neutron stars. A GRB can release as much energy in seconds as our sun will in 10 billion years. A direct hit, even thousands of light-years away, would be catastrophic. It would cook the atmosphere, boil the oceans, and end all life as we know it. Perhaps the filter isn't a violent cosmic event, but something more subtle, more fundamental to life itself. The journey from a puddle of primordial soup to a sentient being capable of building a radio telescope is a long and winding road with countless dead ends. The Great Filter might simply be the sheer improbability of life itself. Scientists still don't know exactly how the first life arose from non-living matter on the early Earth. We can create amino acids in laboratory experiments that simulate early Earth conditions, but getting those blocks to assemble themselves into a self-replicating molecule like RNA or DNA is a monumental leap in complexity, one we have yet to reproduce. Even if simple life gets started, the next steps are anything but guaranteed. For about 2 billion years, life on Earth consisted of nothing more complex than single-celled bacteria. Then, something extraordinary happened. One cell engulfed another, and instead of digesting it, they formed a symbiotic partnership. The engulfed cell became the mitochondrion, the powerhouse of all complex life today. So where does this leave us humanity on our small blue world? The search for extraterrestrial intelligence is more than just a quest to find little green men, it's a mirror. It forces us to look at ourselves and our place in the universe. The Fermi Paradox and the Great Filter aren't just abstract ideas, they're powerful tools for thinking about our future. They frame our current global challenges. Climate change, nuclear proliferation, pandemic risks, not merely political or economic problems but potential filters that will decide if we have a future among the stars. If the Great Filter is behind us, we are indescribably precious. If life is rare, if complex life is rare, if intelligence is rare, we could be the only sentient beings in this galaxy. Think about that. Every piece of art, every symphony, every act of love and discovery, every scientific insight might be the only ones for light years in every direction. That places a profound responsibility on us. To survive, to cherish our world, to protect this fragile spark of consciousness. This is why we must keep searching. Every night our radio telescopes listen to the stars. Whether we're alone or not, the journey to find out is one of the noblest adventures we'll ever undertake.